The rate at which the world's oil is being consumed is this function here in billions of barrels per year, where T is years after 2004. So at every moment of time you have a certain amount of billions of barrels per year of oil being consumed, but the very next moment the rate has changed depending on the time. So we're going to set up a definite integral that will give the total amount of barrels of oil consumed over the time period of 2004 to 2012. So that means that 2004 is times 0, 2012 is times 8. Alright, so I graphed the R of T function, the rate of consumption, and drew some representative rectangles. And you have your picture here. And notice that you have a delta T time interval. So over that small time interval, the rate that you can use to be good for over that time period is the R of T, which is this rate. And when you multiply R of T times delta T, you get R of T delta T. That's the total amount consumed during that delta T time period. It's the same thing as if you had a velocity and a delta T. That would be the distance you traveled over that time interval, rate times time. So in this case it's not distance, it's the total amount of barrels per oil consumed in that delta T time. But you also have the rest of these. So you have to sum these all up from 0 to 8. So the way you should write this out is write down in words what you're talking about. Amount of oil consumed in a delta T time interval is R of T in billions of barrels per year times delta T years. See, this way you'll be able to sort of cancel those years out in your mind and say, yes, I really am getting billions of barrels when I multiply those two together. So I have this amount in the delta T time interval. Then if I want the total oil consumption over all those years, I have to sum all those R of T delta T totals up from T equals 0 to 8, and this is the way I want you to write it. I don't want you to bother with the I counters. We're just putting down here what our limits of integration are going to be from 0 to 8, just to remind us. But I do want you to write down this summation notation, always to remind that we're going from the finite n intervals to an infinite amount of intervals. And this is a sum here of the R of T. I just plug that in. So the exact oil consumption will be the integral as n went to infinity and delta T went down to 0 of your function here. And if you run the left and right sums for n equals 100 and average those, you come up with 314.737 approximate, when you round it off, billions of barrels. Now that's part A and B. Now we go down to part C. We have to get this exact value rather than just approximate it with the left and right sums. So put integral of 32e to the 0.05t into wolframalpha.com. Now you could also put antiderivative of 32e to the 0.05t. You'll get the same result because you're looking for an antiderivative. And then when you do that and press enter, you get this statement right here. The integral, notice they don't have the limits, and they also call it the indefinite integral. Indefinite means you're just finding an antiderivative. You don't have the limits of integration on there to turn it into a definite integral. So they give you this and plus a constant. Okay, well, let's see what that constant does. We're going to check to see if what they gave us is an antiderivative for our rate function. 640 e to the 0.05t plus c. So let's just see. Get some stuff here. Let's see if that differentiates back to what we our rate function. So 64 e to the 0.05t chain rule times 0.05. Multiply the 0.05 over with 640, and you do get the original rate function. Notice that the c didn't matter. Whatever the c was, it just got differentiated to 0. So when we go to use our fundamental theorem of calculus, all we have to do is find an antiderivative of the rate function, and not any specific one, just any of them. So we're just going to take the one that's 640 e to the 0.05t, and we're not going to put the c in there. We don't. So let's just say c is 0, because we just want any antiderivative. So we have one. So that's it. So we use the fundamental theorem of calculus. Our integral is equal to the antiderivative evaluated at 8 minus the antiderivative evaluated at 0. Plug them in. Do this factor out to 640, which you actually could have done from the beginning if you wanted to, and evaluate this all out, and it comes out 314.77 billion barrels of oil consumed from 2004 to 2012, which happens to match up exactly with our n equal 100 average of left and right sums. It doesn't have to be exactly that. In fact, it wasn't exactly checking out. It just rounded off to be the same to 2 decimal places. But basically, it shows that the process is working.